use, instead of standard form, they like to use the y-intercept form. So that's y equals mx plus b. Okay, so this is our y-intercept form, and we'll notice that our y and x's are, of course, our variables. This is what we call slope. So m is our representation for slope, and b is our y-intercept. So it can be pretty standard to look at this. Let's take an example again. If we had y equals something like 1/2 x plus 2. Okay? So if we have y equals 1/2 x plus 2, then we already have 1 point on the graph, right? And that's our y-intercept. So y-intercept is what? Right, y-intercept is when our x is 0. So x is 0 would mean that it's going to be on this line somewhere. That's our y-intercept. And it's going to be a positive 2. So bam, we have a point. So instead of having 2 points and drawing a line, if we have a point and a slope, then all we have to do is apply the idea of rise over run to this, and we can graph it. So if our rise is 1 over 2, we could go up 1 and over 2, right? Also note that if you put a negative on the top and bottom of here, it still keeps this a positive overall. So you can also think of it as going down 1 and 2 to the left. And you can do this either way, but sometimes it's nice to draw 3 points because that way your line's a little bit straighter in general. So here's the line, and if I wanted to label it, y equals 1/2 x plus 2, and voila, here's the graph of this. That's how you graph y-intercept form. How would you solve for other helpful pieces of information from a y-intercept form? Well, if you wanted the x-intercept, you would have to plug in a 0 for y here and then solve this equation for x. So it's a little less pretty than a standard form operation as far as finding what the intercepts are, but it's important still. So the last thing I wanted to cover was obviously we know what the slope of this line is now, is 1/2. If we wanted to deal with these two special cases of lines. Also note, whenever you're drawing a Cartesian coordinate system, be sure to put your arrows on your axes. These technically go on forever. It spans a whole plane, so it's important that you do so consistently. If I give you this line, and say I put ticks here, and that's 3, versus this line, want to see if you can talk about what the idea of slope is for these. So if we look first at this one, normally you would say, what's your rise over run? So in this case, if we start with any point here, we know that there's a point 0, 0, 3, because this point we can talk about 0, 3. Our x is 0 and our y is 3. If we go over another and we want to say what's our point here, well, the x has changed to 1, but the y hasn't changed at all, right? So you can either look at a graph and start drawing points from it based on what the graph is saying,